So welcome, thank you for coming. One thing I will say before I get started is if you haven't attended one of these Zoom webinars before, I'm really excited for the opportunity at the end to answer questions and chat with you all. So if you have anything that you think of during the talk that you want to talk about at the bottom of your screen, see if I can get it to pop up, not when I'm in screen sharing mode. At the bottom of the Zoom window, you should see a little chat button. And so feel free to type questions into the chat and hopefully I'll be able to leave enough time at the end that we can take general questions and talk about things. So as Joe said, my talk is entitled Birdsong, although perhaps a slightly more accurate description would be bird sounds, since songs are certainly not the only sounds that birds make. And the way I'm going to structure this today is sort of in two parts. The first part of the talk is going to be largely about natural history and evolution of bird sound, giving you a little bit of background. And then the second half of the talk will be about how we might use bird sounds when we're out birding and some interesting resources that are out there to help you learn to use bird sounds if you don't use them already, or enhance the way that you use bird sounds in your birding. So one thing that we are going to do a lot of today in this talk, which maybe is going to feel a little counterintuitive, is we're going to read bird sounds. You can do this. You can do this because we can do a mathematical transformation of sound that makes it into a picture. And that is something called a spectrogram here on the right side of your screen. So this is a really lovely example of how to read bird sounds from the Peterson Field Guide to Eastern Bird Sounds by Nathan Pipelow. And here you can see that you can think about reading these spectrograms similarly to how you might read music. So if you read music, you can see the musical score here on the left that's showing just a little bit of the Star-Spangled Banner. And you know that the vertical axis on the musical score tells you the pitch of the sound, and the horizontal axis is going to tell you the duration of each of those notes. And the spectrogram does the same thing. So you have pitch here on the vertical axis and time along the horizontal axis. In this case, however, there aren't different symbols telling you how long the different notes are. Rather, the notes just extend for different periods of time. So here you can see a whistled version of the Star-Spangled Banner. And that's corresponding to what you see on the left. And one other piece of information that the spectrogram gives you that musical notation doesn't give you, which is not very clear in this example, but you'll see it later on in this talk, is the loudness of the sound is also represented by the darkness of the trace of each note on the spectrogram. All right, so just keep that in mind and I'll walk you through how these work again the next time we see one. Can I advance here? There we go. So I thought I'd start off talking a little bit about how I got interested in bird sounds. And that is when I was in high school and first kind of taking off on birding as a hobby, I went on a hike at a local park where I grew up in Central Ohio, and the naturalist leading the hike said, we're going to be birding by sight and by sound today. And boy, he wasn't kidding, because in the dense deciduous forests of Central Ohio, there are a lot of birds that you just don't see, and they're out there. And this was a really informative hike for me. I have very vivid memories of adding several life species to my list at the time that I didn't even see on that hike. But the naturalist did such a good job of stopping and explaining the vocalizations and helping us find them in the acoustic space and identify them, that I can remember where I was on that trail the first time I heard a Louisiana water thrush. And as I proceeded through my ornithological career, I've gotten to use bird sounds and songs more and more. As Joe said, I used them during my PhD work, and so that's when I got familiar with a lot of the technical and natural history aspects of bird sounds, but they've always had a special place in my heart for opening up my eyes and ears to a different aspect of the natural world and making birding more dimensional for me. So as I go through this talk, I'd like you to maybe think about ways in which, why you might be interested in bird sounds too, Particularly think about how it might relate to what kind of birder you are. Perhaps you're a lister and you like to keep track of how many species you see every year in a particular county or a particular place or just over your lifetime. In that case, using bird sounds can really help you expand your species list by helping you identify birds that are hard to find visually. Maybe you're more of a naturalist in your birding style. You're not as focused on getting as many species as you can, but when you go out, you really want to get acquainted with the birds that you see, in which case understanding more about bird sounds can help you really dive into a different and deeper understanding of bird behavior. And the last thing is maybe you're looking for a new hobby. There's a lot of people who photograph birds, which is a wonderful and fun hobby to have. It turns out there's also a lot of people who are getting into recording birds. Personal recording equipment is becoming reasonably affordable, and there's a lot of good tools and tips out there so that you can record bird sounds not just for your own enjoyment, but you can also upload them to community science databases. All right, so getting into some of the background about birds and sounds, first we'll talk about how birds use sounds. One common way that birds use sound is in mate attraction, and this is predominantly done through song. Another is territory defense. So birds will basically vocally stake out the limits of their territories to let other birds know, like, don't cross this line, buddy. Bird sounds are used in social cohesion behaviors, so things like flocking, or increasing pair bonds among mated pairs that aren't necessarily mate attraction, but just reinforcing that existing pair bond. Sounds can be used to coordinate behavior. I'm sure all of you are familiar with being out in the woods and hearing a whole bunch of birds start up pitching. You start looking around and find yourself that hawk or owl that they're trying to mob. So in that case, they're coordinating the behavior among multiple species to try and drive out a threat. They can also coordinate behavior within species to do things like food sharing. Ravens are really famous for doing this. It can elicit feeding from parents. So chicks will beg to get the parents to feed them. And also coordinating behavior might involve establishing or maintaining dominance hierarchies. Another way that birds do use sound that we're just starting to understand is something even more similar to human behavior, and the best system for studying this so far has been Carolina chickadees. And it turns out that chickadees actually use syntax. That is, they have sort of a grammatical structure that affects the meaning of the calls in their chickadee call. And so the order and the number of notes in the chickadee call can denote things like predator type, predator location, the particular type of attack that might be imminent as a result of that predator. And that's something that I personally suspect there's more birds out there that have grammatical syntax, and we just haven't hit upon it yet, but it's pretty interesting to see that's been well studied, at least in the chickadee system. There's a few general types of bird sounds. I'm just going to touch on them today. Like I said, we're mainly going to talk about song, but there's other types of sounds to think about. So song is typically thought of as these long, musical, melodical vocalizations. That's probably what you imagine when you think about bird sound. It's very visible because song is predominantly used in mate attraction and territory defense. And so by nature, it's intended to be broadcast out in the world to all of the other birds around to try and attract females or repel rival males. And so it's easy for us to cue in on song as well. One interesting aspect of song is that we have traditionally thought of it as being a male trait, but it turns out that recent research has revealed that thought process might be actually a result of the bias of who has been studying birdsong and where they've been doing it. So a lot of birdsong research has been done in temperate North America and Europe. And in those areas, in fact, most of the birds that are singing are males, and very few females sing within species that breed in temperate North America and Europe. However, once you move into the tropics, it turns out female song is incredibly common. And you even get these really fantastic behaviors where the males and females within a pair bond coordinate their songs into these complicated duets. And when you look at the evolutionary history of birds, it turns out that we're reasonably confident that the early evolution of songbirds, both male and female birds sang, and subsequently in those temperate birds, the females have lost the ability to sing. So that's really exciting and interesting. Another type of bird sound are calls. So calls sort of encompass everything that's not a song. They're short, they're typically not melodic, they tend to be innate, meaning that the bird does not need to learn those things over their lifetime, they just develop naturally in the species typical way. And calls serve an enormous number of functions. So basically anything that's not mate attraction or territory defense is going to fall under a call category. And then the last type I want to talk about, we're just going to touch on here, but it's so cool I can't leave it out. And those are non-vocal sounds. So both songs and calls are made with the bird's voice box basically, but birds do make a lot of sounds that they're not using their voice box for. One example is the booming in sage-grouse. So you can see this lovely picture here on the right, the bright yellow air sacs are visible on the sage-grouse. So this is actually still a part of the respiratory system of birds, but it's not using the vocal tract itself to make that resonant booming sound. And American bitterns, we think that bitterns also use those air sacs in a similar manner when they do the bittern call, which has some vocal components as well. The next category of non-vocal sounds that I want to touch on are feather sounds. So it turns out that birds actually make quite a lot of noise with their feathers. Probably the most familiar one to you are mourning doves. Every time you hear a mourning dove take off, you get that lovely whistling sound. That's actually the feathers making that noise. Woodcock are another common example. When they do their display, there's a whistling that's generated by the outer primaries on the wing feathers. And then I really love this example from research by Hogan and Stoddard recently that shows a broad-tailed hummingbird flight display. You get this long swooping display of the bird, and during this time you can hear the sort of like a buzzing sound while the bird is doing this, and they've color coordinated these two figures so you can see the trajectory of the bird on its display. And then if you look at this spectrogram, our visual aspect of the sound, you can also see those colors coordinated to the particular sound that's generated at each point during that display. So again, remember your horizontal is going to be frequency here, and your vertical is frequency, your horizontal is going to be time. And these birds are actually making a combination of sounds that are coming from wing and tail feathers during the course of this display. That's an important component of, and this is a mate attraction display. And then there are percussive sounds. So anybody whose house has ever been used by a northern flicker to advertise its presence to the rest of the northern flickers can really appreciate how far these sounds can broadcast, because they make your whole house into a drum. So woodpeckers are certainly using their bills to dig into trees, to dig out food sources, but they also are using them as a mechanism for communication, where they're pounding out on a hollow log or something that resonates well, to advertise to other woodpeckers where they are. But another cool example of drumming behavior that's been recently studied is in the palm cockatoo in Australia. And what makes this, there's two things that make this incredibly interesting in this bird. First of all, palm cockatoos, unlike woodpeckers, they're not just using their beaks or some aspect of their body to drum on another object. They're actually creating tools. They'll break off a stick and get it to the size and shape that they want. and use that stick as a tool to beat against a hollow log or as a drum. So first of all, they're using tools, which is incredibly cool. Second of all, each individual male palm cockatoo, they're using these drumming behaviors as mate attraction displays, and they establish their own drumming pattern that is unique to them and repeated over time. So it's not random. They have a particular rhythm that they use over and over again. And scientists are really interested in looking at this and trying to understand the way in which rhythm is important in other animals, including humans. And there are not a lot of other examples of animals using rhythmic percussion in this way. All right, so we're going to move away from the non-vocal sounds now, but do keep them in mind because they're really useful when you're out birding, and also they're just incredibly cool. We're going to talk a little bit more about the vocal sounds for the rest of the talk. And before we get into the sounds themselves, there's one other thing I want to touch base on, and that is how the sound is produced. So in mammals, including humans, our sound producing organ, our vocal cords are in our trachea, and they're basically a series of tympanic membranes that vibrate when air passes over them, and that's what makes the sound. And the variation in that sound is controlled by the constriction of the trachea, as well as, you know, how we open and move our mouths and our necks while we're speaking. Well, birds have a similar sound producing organ. It's also a tympanic membrane that vibrates when air is passed through it. However, they have two rather than one. And those sound producing organs, rather than being located up here in the trachea, are actually located a bit lower down, right at the split for the trachea and the bronchi. So it's each aspect of the respiratory system is headed towards the respective lungs. And as I said, so the sound is still produced in the same way mechanically. It's still air moving past those tympanic membranes, and the membranes themselves are still having the sound altered by the constriction of the trachea. But there's a complex series of musculature that's helping do that. And birds also have some additional aspects to their respiratory systems that humans don't have, air sacs that help control the compression of those tympanic membranes as well. Now, this has some really interesting implications for bird sound. And one of those is that the two different syrinxes, the two different sides of the respiratory tract, can actually allow the birds to make two different complex notes simultaneously. So again, you're seeing pitch on the vertical axis and time across the horizontal axis here. And this is a bird that should be familiar to you. This is a wood thrush. So we'll play it here first. You can just listen. And what you should maybe don't pick up on right away when you hear it, other than the fact that thrushes have this very ethereal sort of feel about them. But you can see very clearly on the spectrogram, we've got the sound boo 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 doo boo doo. And here on this fourth note, you'll see there's a dark trace that kind of comes up and then becomes flat. And then there's a lighter trace underneath it that's perfectly flat. So that's the two different sides of the vocal system making two notes simultaneously. You see that again here, where you have a slightly curved trill and a flat trill underneath. And then most impressively, at the end of the song in this series of trills, where one side of the vocal tract is making this enormous down swooping trill, while the other side is simultaneously making this shorter up swooping trill. And that's what gives you that really sort of ethereal harmonic sound that many thrushes have. Why not listen to it one more time? Another thing that this allows birds to do is actually alternate sound production between the two sides of the respiratory tract. And that allows them to make these really rapidly produced sounds that mammals just simply could not do. And so what you're seeing here, this is a spectrogram of a bird that hopefully you're not hearing when you're out birding here in Maryland. This is an Atlantic canary. If you have cage bird, then maybe you hear this on a regular basis. And you can see in the center here a nice example of that dual voicing, again, like we saw in the thrush, where we have one sort of stable note being produced by one side of the vocal tract, and then this down swooping frequency note being produced by the other. And we'll listen to that. But the part I sort of want to attend to here is the second half of what's in this yellow box, and that is this rapid series of trills. And what's going on here is actually that the two sides of the vocal tract are taking turns, as it were, and you're getting you're able to produce these really rapid downswept trill notes because the two different sides are taking turns. And humans, to us, it just sounds like almost machine gun like. Birds actually have faster auditory processing in addition to faster ability to produce these notes. So they're maybe a little more tuned into it than we are, but it's really astounding. One other incredible aspect of vocalization in birds that is song learning. So the ability to learn vocal sounds over the course of a lifetime is something that very few groups of animals can do. Humans, obviously, are vocal learners, also dolphins and whales, and some species of bats, and then birds. And that's pretty much it in the whole animal kingdom. You have very few groups of animals that do this. And within birds, there's actually 3 separate evolutionary lineages of birds that learn their sounds. Hummingbirds, over here on this tree, parrots, and then songbirds. And obviously the songbird radiation is the largest of these 3, but you can appreciate that these birds are pretty distantly related on the bird family tree. And so this behavior has evolved multiple times. Song learning has a couple of components, and in birds, the components of song learning are very closely allied to the ways in which human learning happens, human vocal learning happens. And so birds have actually become a really fantastic model for understanding vocal learning in humans, even though we are 300 million years more or less from our shared common ancestor. The first is a critical learning phase. So this typically happens as chicks are in the nest and leaving shortly thereafter, leaving the nest. And during this time, just like in humans, if birds aren't hearing the appropriate species typical sound, then they will not be able to form a template for them to produce that sound later in life. So perhaps you've heard that in humans, the critical learning period is much wider and it's not quite as concrete, but anybody who has kids that are learning a second language in preschool or kindergarten can certainly appreciate how much faster they pick it up than if we try to pick up a second language as adults. The next stage is similar to baby babbling. And so this actually is broken down technically into a couple different groups, but you can think about it as generally as a babbling and practicing stage. So the template, the mental template is there. And now the bird is practicing producing the sound and comparing that sound to their mental template and gradually improving and in some cases improvising as well. And that gradual improvement and practicing stage has different time periods in different species. And then finally, there's this fully formed adult sound, adult song, which is called the crystallized song. And as an example of that, here we've got 2 white-crowned sparrow songs, white-throated sparrow. So I'll play the adult version for you here, and you'll see the whistles on the spectrogram. And so below you see the adult sound, and then above you're seeing what's called the sub-song of the juvenile song. So this is kind of late in the practicing stage. All of the notes are more or less there. You can see them here. They start and stop with roughly the correct adult time frequency. But whereas the adult has this beautiful, pure whistle, listen to what this young bird is doing. So they're sort of quavery, they're quiet. You can see that on the spectrogram too. There's a lot of modulating. It sounds like this poor bird is very nervous. And so they'll continue practicing this, and some of it is trying to still learn the song, but a lot of it is coordinating that muscle with the template that they have. So in songbirds, most learning occurs from the parents, but also from the surrounding neighbors in the area. And most birds are imprinting on their species typical song right as they're leaving the nest. So they're imprinting in their natal habitat, and then going off, if they're migrants, going off to their wintering grounds, and then coming back and maybe coming back to the exact same territory area, maybe going somewhere slightly different. But some of the implications for this are that song types can persist in a population a lot longer than an individual bird. So if each chick is learning its song from its parent, and presumably that parent learned from their parent, you get this intergenerational passing down of a single trait that's lasting a lot longer than the lifetime of an individual bird. You also have the opportunity for mistakes and innovations to quickly introduce themselves into the population. So because there's a learning aspect to this, then not all songs are rendered entirely perfect from the first version. So then you can imagine if the offspring of that bird learn the slightly innovative version, then you can get changes over time. And also you can have song types that spread through the population in a different pattern than genes. So you can have this song type that comes in this vertical transmission, parent to offspring, but also if that offspring is listening to a neighbor on a neighboring territory, they can pick up the song of an unrelated individual and incorporate that into their repertoire or pass that down to their offspring. So you can spread songs in the same way that you spread genes, or you can spread them in a different pattern than you spread genes. And this is how birds form dialects. If that song tends to be stable in a region and related to, and learned from individuals that live nearby and has some variation from songs found in other parts of that species range, then you get dialects in the bird's song. A really interesting aspect of dialects is that sometimes they can move faster than genes. So a neat example of this that has recently been studied is white-throated sparrows. And we listened to the white-throated sparrow song just a few minutes ago, right? Oh, sweet Canada, Canada. That's what we're familiar with here. But it turns out there's another version of that song that's sort of going viral. On these maps, you can see the two different versions represented by two different colors. And you see this blue version, which is a two syllable version of the song. So instead of oh sweet Canada, it's like oh sweet Canada. And that song type was noticed by birders and scientists in Western Canada. And pre-2000, it was very uncommon. It's mostly in Western Canada. So we'll go ahead and play it here. Maybe that's our 3 version. And let's listen to the other version. do, 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 do. So that's our 2-syllable version there. I apologize. Just sounds a little cut off. But over time, you can watch as the occurrence of that 2-syllable version marches westward and becomes much more common. So keep your ears out when you're out birding these days. See whether our birds are starting to pick up the Western Canada version of this song. And in this case, you know, this is happening over the course of 20 years, which we can call that 20 generations of white-throated sparrows, but that's much faster than evolution would drive the spread of those genes under normal circumstances. So another way that dialects can work in the opposite way is to reduce gene flow, and in those cases lead to speciation. So especially if a song is important in mate attraction or territory defense, such that it would prevent genes from being shared between birds that have different preferences for a dialect type, then it can basically just act as a barrier for genes spreading between those populations, and that can allow evolution to go in 2 different directions within populations that have different dialects. One more aspect of birdsong that we're going to touch on quickly before we get into how birdsong affects you when you're out birding is the idea of repertoires. So many individual birds have lots of versions of their own song, and that's the repertoire. And repertoire size tends to be species specific. There's a little bit of individual variation, but on the whole, you can say swamp sparrows will always have just a handful of songs, 1 or 2 or 3. But a mockingbird or a brown thrasher, any given individual bird can have hundreds or thousands of song types in their repertoires. And then there's the real weird outliers, like the gray catbird, which is just the true musician, jazz musician of songbirds, where rather than having a particular repertoire of stereotyped songs, the catbird just has this enormous like compendium of syllables that they rearrange into this sort of scatting, fun jazz rendition, and they don't have repeated song types. So when you're trying to learn bird sounds and you're trying to tackle a bird with a repertoire, this can be really frustrating because each song sounds a little bit different and each individual has a slightly different repertoire, and it's just, you absolutely cannot learn it by rote memorization. So in that case, you kind of have to focus on cadence or pitch, the overall delivery style to try and recognize that particular song type. And a classic example of this is the Carolina wren. You can often think of them as saying tea kettle, tea kettle, tea kettle, but every now and then it sounds like cheeseburger, cheeseburger, or beef eater. And you just have to kind of remember it's this galloping, whistling sound. So how does knowing bird sounds help you when you're birding? Well, the first thing it might do is just alert you to the fact that there's a bird in the vicinity. So for me, one of the birds that's the best classic example of this is a bluebird flight call. Now, bluebirds are fun and easy to see when you spot them. They're nice and bright, and they like to be, out on fence posts or sort of along hedgerows and things. So they're at eye level in open habitat, but I did not realize just how many bluebirds were in my life until I learned this flight call, and they have this very almost muted, like toot-oop, toot-oop. And so now I know bluebirds are around me all the time and I'm just not aware of it. Another way is it can help you find birds that aren't easily visible. So bluebirds are reasonably easily visible if you're looking in the right direction. A bird that is not easily visible under most circumstances is the American bittern. Out there in a marsh, in the dense cattails or vegetation, but when you hear that call, then you know they're out there. You can add it to your list. Hopefully you can zero in on it and actually see the bird as well. Knowing bird sounds can help you discriminate between 2 visually similar species. So a classic example of this are the Epidnax flycatchers. willow flycatcher versus Acadian flycatcher versus alder flycatcher. Good luck to you telling these apart by looking at them. You really just have to hear them sing. And as soon as you hear them sing, you know which one is which. And another thing they can do is help you key in on what kind of behavior to look for. So like I said earlier in this talk, if you hear song is intended as this long distance broadcast mode of communication. So if you hear a bird that's singing, you know you're wanting to look in a prominent place, right? This bird's probably going to be up high, maybe out on an empty branch. It's a place where it wants to be seen and heard by other birds too. It may not be moving, but hopefully it'll be visible to you. If you hear alarm calls or pishing, you expect the birds to be moving around rapidly, kind of maybe even skulking, and you might be on the lookout for a predator. If you hear begging calls, you know you're looking for multiple birds, at least one young and one parent, possibly multiple young and parents, right? The young are probably going to be fluttering their wings, trying to visually attract the parent as well as vocally. So that can kind of key you in on what type of behavior you're looking for. You might hear little chips or beak snaps. Warblers are really classic for these little beak snaps when they're foraging. And so that's got you looking up in canopy for little birds flitting around. Or one of my favorites when you're thinking about looking for a type of behavior are contact or flocking calls. So I mentioned the bluebird flight calls. This is one that to me just, I don't know that I've ever seen these birds without hearing them first, certainly not in Maryland. And it's a sound that I'll play for you, and we'll see how many people recognize it. Then I'll tell you what it is. And the second I hear that, I'm looking straight up at the sky and trying to find that big old flock of sandhill cranes moving through, because those guys are really a special treat. One of the tricks when you're learning songs and calls are something called mnemonics. And mnemonics is basically just a way to tie in a phrase or some other kind of memory device that approximates roughly the cadence and the pitch of the sound that the bird is making that will help you remember it. And if you're out with somebody and learning these in the field, this is probably how you're going to learn it, right? This is how a lot of people have learned bird songs classically. So we have the Eastern towhee, drink your tea, and then the call, which conveniently says the bird's name, towhee. So those are sort of the classics. Another one I like very much is the goldfinch flight call. A lot of these are food-based. Potato chip, potato chip. Or the red-eyed vireo. And this is an example of a bird that has a repertoire. And so the mnemonic for the red-eyed vireo that I know is cherries, have some, take a few. And for us, that phrase is sort of a three-part phrase. Seems like the whole thing, but for the vireo, each part of the phrase is its own song. So cherries is a song, have some is a song type, and take a few is a song type. And so they don't always repeat them in the same order, and it may not perfectly match, depending on the individual, may not perfectly match the mnemonic, but it gives you that pattern to think about. When we're birding visually, we talk about general impression, size, and shape to try and cue ourselves into the way a bird looks. I would argue that we can do that with sound too. Maybe a general impression, tone, and pitch. So in this case, rather than trying to memorize a particular song, think about a sound as sort of its elements. Was it a clear whistle? Was it a trill? Did it have sort of this burry, throaty aspect to it? Was it high or low? Was it an ascending or descending? And these will kind of send your brain in the right direction. So instead of thinking about this, trying to memorize the sound itself, you're sort of trying to think about generally how the sound comes across. You can also think about whether it's a repeated motif. Does it repeat the exact same way every time? Like the Toei, drink your tea, or is it that red-eyed vireo? And there's variations on the theme connected to one another. There are lots of good resources for learning bird sounds out there. Good classic one are CDs or MP3s. So I will caveat this section of the talk by saying that I'm not recommending any particular one of these products. In fact, I have not used most of them personally, but they are out there and they are offered different ways of learning bird sounds, all of which can be good depending on what kind of learner you are. So these sort of classical, it's almost like a field guide in auditory format. They tend to be organized taxonomically, and they have some species typical vocalizations for each of the species that they cover, which is really nice. If you just want to listen, like say, oh, I really want to hear what the difference is between a great horned owl and a barred owl. Woo, 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 versus who cooks for you all? However, I can say from experience, if you've been out in the field and you've heard a sound and you've got it in your memory and you really want to know what it is, trying to listen through this compendium of sounds with very little reference point can be extremely frustrating to try and find your match. There are some great websites out there for bird sounds right now. Two really excellent ones are Xenocanto and the Macaulay Library. All of these songs that I've been playing you in this talk are from Xenocanto. So these are both of these are places where you can reposit recordings. They're largely contributed by amateur or hobbyist recordists, but also professionals as well. You can search and view existing recordings of particular species, just like you could on those CDs and MP3s, like just type in, I want to hear barred owl. It will give you a whole example of recordings that you can listen to. You can contribute your own recordings and archive them on both of these websites. They also offer tips and tricks on how to record birds, how to identify bird sounds, and both collections are global in scope, but primarily are going to include species from North America. Xenocanto is audio recordings only, but it is open access content, so that's how I am able to use all these recordings in the talk here, because they're all Creative Commons licensed and open access for you to download. Macaulay Library includes not only audio recordings, but also photos and videos, and that's where your eBird photos go. If you're uploading photos with your eBird, those are going to Macaulay. And the content is viewable for free, although not all of it is downloadable for free. And then next, I'm going to talk about a couple of apps that I am really excited to try out for birding by ear in the field, because they just seem like they open up a whole new avenue. The first is the Merlin app by Cornell. So you may already be familiar with Merlin because it is very useful for visual identification as well in the field. Like a field guide, you have these taxonomic organizations of species you can see on the left here. You can click on a particular species to get some information about that species. And then if you go to the little sound icon in the middle here, you can see a series of example recordings for that species, which you can play. And it will play for you the sound and also trace out the spectrogram at the same time. So you can practice reading these sounds at the same time as you can practice hearing them. And it gives you a variety of examples of vocalizations of those birds, not just the songs. So for this field sparrow here, we have a couple different song examples, and we have a few different call examples as well. And then there's this one, which I personally am really excited to start using and try out, and that is the Song Sleuth app by Sibley. So like Merlin, Song Sleuth, you can just go in there and look at it sort of taxonomically or by birds that are common in your area. You can, both of these apps you can reduce to just the birds that are most likely in your area. And you can click on a bird and you can learn a little bit about it. And then you can go and see a series of recordings for that bird, different examples of their vocalizations. In this case, we've got a few different song examples for Carolina chickadee, as well as a few different call examples. You can play them. You can look at the spectrogram. And then interestingly, if you click on this little button here with the musical notes, Song Sleuth will suggest to you other species of birds whose sounds are similar to that bird. And you can play them and compare them and look at the spectrograms and compare them as well. So if you're really trying to get a handle on learning bird sounds, this one to me seems like it has the greatest opportunity for learning. And then it also has this really cool feature where you can record the bird sound with your phone. And then it sort of does a Birdsong Shazam thing where it compares your recording to recordings that it has in the program and comes up with a list of matches for you. Now I have to say I haven't tried this feature yet, and reviews are mixed as to how accurate it is, but certainly just the opportunity to record your own sounds with your phone and have a look at the spectrograms and make comparisons to the other similar species just allows you a guided tour, as it were, of learning bird sounds. And you can also store your recordings within this app, either for upload to another community science website, although presumably the microphone on your smartphone is not really high enough quality for these to be super useful for other people, but you can keep them as a reference for yourself to understand, what have I been hearing, what have I been identifying, and how does it compare to what else is out there. And the last is another interesting resource, and I mentioned this at the beginning of the talk, the Peterson Field Guide for Bird Sounds of Eastern North America. And I have to confess, I was a little skeptical at the idea of a book that would teach you bird sounds. But I'm impressed with how they've organized this. And they do have a website series of MP3s that link up with the book so that you can listen to the sounds as well. But this book really teaches you to think about bird sound in that general impression model, and to think about how it might look on a spectrogram. So for example, it might suggest to you, do you have a series of accelerating notes into a trill, or a trill that decelerates into a slower series? Or do you have multiple consecutive series separated by pauses? And it just gives you kind of a different way of thinking about the sound and breaking it down, much like you would for a dichotomous key for plants. Are the leaves opposite? Are they lobed? Are they fuzzy? It just kind of guides you through how you're thinking about sound. And then in true field guide fashion, there's a page for each species that gives you a little visual of the bird and a range map and spectrograms of some of the representative sounds that those birds make. So that's an interesting resource that's out there as well. All right, just to kind of wrap up here, we started out talking about how birds have a variety of mechanisms for producing sounds, both vocal and non-vocal. All the vocal ones are probably the ones you're most likely to key in on when you're out birding. We talked about the anatomy and neurophysiology of bird vocal cords and respiratory systems, and how that actually allows them to produce some of these really complex vocalizations. We touched on how learning as a neural process adds a mechanism for bird sounds to change over time and across geography. and then discussed how attending bird sounds can enhance your birding experience and some of the ways in which you can, resources you have for attending to those sounds and learning them. And there are the resources. And with that, I will stop my screen share here or just open up the chat and be happy to take questions.